Axens became the technology licensor of Rewind PET. With the support of the French Environment and Energy Management Agency, this collaboration has resulted in the construction, commissioning, and recent startup of their Rewind PET semi-industrial unit.
Thank you for your presence. I am Jeremy Labat, and I work in Axens group. So Axens is a French group specialized in licensing and catalyst for the petrochemical and petroleum industry, belonging to the IFPEN. But Axens is also now specialized in the new domain, and typically the plastic recycling world. On my side, after several years working in the industry, I joined Axens, and I could have the chance to work for the plastic chemical recycling, typically the PRSE way, for around 5 years now. During this presentation, if you have any question, don't hesitate first to scan the QR code and then to address your question in the app directly in order to receive them and to answer them at the end of this presentation. I am glad to be with you today to discuss about large-scale industrial deployment of chemical recycling of waste plastic. Based upon industrially proven technology, we are targeting PPWR 2030 objectives. And I am happy to make an announcement of a new project in the conclusion of this presentation. First of all, this graph for a global overview of our portfolio, the full Rewind solution proposed by Axens. On top of this slide, in order to treat the mixed soft polyolefin waste, Axens is already licensing the tag process developed by our partner Plastic Energy, associated to the Rewind Max technology and the Rewind Mix technology for the purification of the pyrolysis oil. Concerning PET, both packaging and textiles can be treated with our Rewind PET depolymerization process. And we will soon complete the picture with two new processes. The first one, the Rewind S, which is a dissolution and purification process for rigid plastic, which will improve the yields and the final product quality compared to mechanical recycling. Last technology will treat PVC with the Rewind PVC. Now, a focus on the Rewind PET technology. As you may know, Axens, with our partner J-Plan, own a semi-industrial unit in Japan, which enables us to demonstrate the robustness of the technology, the strength, the performance, and also the flexibility. Flexibility, you can see that with the packaging application, as we could treat several feedstocks, like post-consumer European packaging feedstock, post-consumer Japanese clear packaging, and post-consumer European multi-trade layers. All these feedstocks were different in shape, in composition, contaminants, but all could lead to recycle PET, and then in the end, bottle production and qualification with food grade quality. This food grade could be checked and validated by our brand owners. concerning the semi-industrial unit itself, it was put in operation around 1 year ago and could treat more than 500 tons of waste plastic, and with a yield which is very good. The first objective of this semi-industrial unit is to test feedstocks, to optimize the parameter, to adjust the performances. But you can already see that we obtain a good record in terms of continuous operation with more than 60 continuous days, which enable us to demonstrate the performance and which make us confident in the stability and the reliability of this technology. Flexibility, we also have it on textile application. This unit could treat several kinds of textile, like post-industrial polyester textiles, post-consumer Japanese, post-consumer European. All these textiles are different and at the time in terms of shape, behavior, but thanks to the flexibility of the unit, all these feedstock could be processed and transformed into BHET of good quality, because typically the quality was identical to the one from packaging. Now, I propose to switch to the pyrolysis pathway. So, from the waste plastic until the virgin-like naphtha at the inlet of the steam cracker, typically. So Axens is licensing the TAC process, so developed by Plastic Energy, and which enable to produce the pyrolysis oil. In order now to increase the yield and for maximizing the carbon recovery, the Rewind Max technology has been developed by Axens, and finally the Rewind Mix to purify this pyrolysis oil in order to make it completely compliant with the specification typically at the inlet of the steam cracker. For the whole chain, the global yield which can be obtained is up to 85%. First part is the TAC process, we said, and what is important is the industrial aspect. So this technology had been industrially proven thanks to two aspects. The first one is the two Spanish plants belonging to Plastic Energy. So the Sevilla plant and Almeria plant in operation for 10 years now. 10 years during which Plastic Energy could and can provide with reliability and safety pyrolysis oil to the European petrochemical players. That's great strength also on commercial aspect, quality, reliability. And the second aspect is the recent startup of two new plants. The first one in Gelen, which is a joint venture between SABIC and Plastic Energy, started last year and which delivered very good performances. And quickly followed by the second plant in France, Grand Prix site, belonging to the Total Energy and Plastic Energy as a JV, and recently started up in 2026. Axens, we are present and we support our partner for the startup and ramp-up phases. These months of startup and operation, typically from the new plants, especially again plant, were very instructive for us. we could demonstrate and see the good behavior, the good adaptability and stability of the plant, and also we could learn from this startup. And typically, we could see that the main challenge, especially in Geleen, has come from the management and conveying of the flakes up to the inlet of the process, so typically the extruder. And that's in good part due to the specificity of the material, the flakes, which are very low density with a specific behavior and particular characteristics, and that will required a very specific design and adjustments. Of course, we know and we could see that the plant can also deal with agglomerate, which is very comfortable, in particular for large-scale plants, thanks to the high density of the product, thanks to the fact that we can handle it in closed loop, completely automatically, and the fact that it improves the performances of the extruder. Naturally, it's also possible to consider flakes for a larger capacity if required by the situation, by the market. Now, some word about the scale-up of the technology. Grand Puy and Geleen project were started and developed around 6-7 years ago. And with the capacity typically for Geleen of 20 kilotons per year, reaching a yield of 70%. In parallel, 4 years ago, 5 years ago, Axens and Plastic Energy signed their partnership and could improve the technology, typically by increasing the size of the reactors without changing the core principle of the reaction, with electrical heating of the system, and with the rewind max in order to increase the yield. So the result now is that we can propose a design for the same capacity with 2 reactors only and the yield reaching 85%. That significantly improve the economics of this kind of project. Last last part of the pyrolysis way, the rewind mix technology. Because even if the pyrolysis oil produced by the TAC process is very good quality, it still have some contaminants, and it boils in the range from the naphtha to the distillates. We also analyzed other pyrolysis oil in the market, and we could see more contaminants. We could see that some oils were solid at ambient temperature, that some others have a final boiling point at 600 degrees. And you probably know that the new voted mass balance in the European Union indicates that if your distillate or distillate plus cuts cannot be incorporated in the stream cracker, the associated credits are lost. Fortunately, there is a solution coming from the refining and petrochemical industry, the hydroprocessing with pressure, hydrogen, and a specific hydrotreatment catalyst. That's what we developed, the rewind mix technology, developed by IFPEN and our partner Repsol, and based on experience and feedback for a lot of references in this field, and which enable us to propose, in the end, a complete purified pyrolysis oil compliant with the specification of the steam cracker, so virgin like naphtha. And the rewind mix can have a hydrocracking part in order to convert all the distillates and obtain in the end only naphtha and a few LPG with a yield of 100%, which in the end enables to obtain 100% of the credit. Now, some word about the life cycle analysis. As we talked about pyrolysis way and pyrolysis oil, it's fair to talk about this topic and the environmental footprint, also because it has been criticized for a long time. Thanks to the recent improvement on the technology, especially on the yield, we can see that the life cycle analysis and the CO2 saving, so from a scheme starting at the waste plastic to the virgin like naphtha, in terms of CO2 saving, we can see that the recycled naphtha produce less CO2 than fossil naphtha. So the gap is 18% without considering the electrical heaters of the reactors and without considering the incineration of the plastic which is not recycled. Because if the plastic is not recycled, generally speaking, it is incinerated. And if we consider that, we find that the CO2 saving can reach around 2.8 tons for the recycled naphtha with the pyrolysis way. If we could consider the electrical heating, this figure could reach 3 or even higher than 3 ton equivalent savings. As a conclusion, some words. On the pyrolysis way, the technology is industrially proven. The scale-up has been optimized for high capacity to be ready for the market and the future targets. The LCA have been significantly improved. And on the PET, we have a full flexibility on packaging and on textile. And thanks to our semi-industrial unit, we ensure the scale-up of this kind of process. Finally, we are happy to take the opportunity of this presentation to announce that we will start a new project on the pyrolysis way, on the full chain, so including the tag process, the rewind max and the rewind mix of 250 kilotons per year of plastic to recycle, leading to more than 200 kilotons per year of pyrolysis oil, which will save 600 kilotons per year of CO2. And we will also start a new project on the PET recycling for the feedstock between 150 and 200 kilotons per year. Thank you for your attention. So about the question, so what is the fractional composition of the pyrolysis oil and ash content? So typically, as I explained during the presentation, the pyrolysis oil can be considered as a mixture between naphtha and distillates. I don't know exactly about the ash content, but if talked about the solid residue, yes, it's composed of ash and also other element, typically carbon, but I cannot give here the exact composition. I can say a few words on Rewind S. Indeed, so it's a process which is specifically developed to treat rigid polyolefin, rigid plastics, and the principle is to, would say, two main steps. The first one is the dissolution of this plastic, and then the purification. I cannot disclose more on this meeting, but if you are interested in this process and if you want to have more information, don't hesitate to go to our booth, Axens booth, in order to discuss and to see how to continue together. About one question about the capex. What is the capex saving on of increase the reactor size? It's also difficult to disclose figures in this meeting, but I can say that the capex per ton is significantly improved by these changes. And also, if you are interested in figures or details, don't hesitate to come to our booth and to discuss together. How would you think of it? So how about dismantling of product or laminate to assessment recyclability? What I can say maybe on this topic is that but typically we have tried to optimize the yield. So as you see that now we are quite close to 100%. And we are also developing solution in order to valorize the remaining 15% and typically the gas. Some solution exists. It's also the same. If you are interested in some details, don't hesitate to come with us to discuss on this topic. Last question, two questions. So one question is about the yields. How to improve from 70 to 80% a process that is just based on thermal decomposition of waste, while the yields are mainly influenced by the waste composition. The principle is, or typically that's the Rewind Max technology. So another time to go into detail, we can see how to discuss. But in 2 words, the principle is to valorize the light part of the product out of the reactors and out of the tech process. Some products are can be valorized, and the Rewind Max is here to optimize this valorization. And in the end, thanks to this valorization, we can catch and valorize better these lights. So is the reactor technology continuous process or semi batch? So it is continuous. It's typically continuous because it's sequential. So the principle is typically like a car with a piston. And thanks to the reactor working alternatively, we are able to continuously produce PRSE oil and with a stability in the process. Are the contaminants removed during hydrotreatment or prior? So I would say that both. We can remove some contaminants already in the tag process and Rewind Max technology. So typically it's what is done. And the complementary treatment, more deeper, is done in the Rewind Mix technology, in the hydrotreatment. I think that's all for the question. Ah, new question. Is your feed constantly? Is your feed? New question is your feed constantly at the same input feed? Yes, the inlet of the unit remain always the same, and there is a flexibility on this inlet in order to accept different kind of feedstocks. Depending on the shape and the manufacturer, we can anticipate that in order to also to give the best flexibility depending on the products you want to consider during the design phase. So can a flexible film made of PET, PE be recycled using this technology and process? So in terms of technology, yes, the technology is very flexible in terms of composition and can accept some percentage of PET in the polyolefin unit. So typically the tag process Rewind Max. Naturally, the amount of PET should be limited first mainly for the quality of the oil and up to certain unit for the flexibility of the unit. But usually we don't have any specific problem with film which can contain a little bit of PET if the amount is restricted. What do you do with? So what do you do with the pitch remaining from the reactor? Is this waste? So typically, what remain the reactor is, can also be valorized, and that's the objective. So typically, to have also a kind of price on this byproduct in order to also improve the economics in this way. Are you receiving MPO from households as feedstock? We can study into detail depending on the quality of this feedstock, but I would say that yes, it could be possible. So one question about the cost. What is the magnitude of processing cost of the new technology without feedstock cost? So another time to disclose figure on this topic, it's better to discuss on our boss. But we can say that on the current market, processing this way is clearly profitable. Tic-tac. There was another question. The chemical recycling can be treated as a post-consumer recycle. So if the question is about the polyolefin, typically the feedstock of the tag process is usually post-consumer plastic. The last question which just appeared, the 85% only oil or also includes the gas and char. It is possible, yes, to reach 85% of oil, only oil. It is possible. depends on the settings, on the parameter, on the quality you want, on the typically on the stability of the oil. But yes, it is possible to obtain only oil at a yield of 85%. So comprehensive, yeah? Thank you. Was the study third-party verified? I suppose that the question is about the LCA. So if it's the case, yes, the LCA has been managed by an independent society specialized in life cycle analysis. So if it's okay for everybody, I thank you very much for your attention, and I wish you a good afternoon, a good day.
Axens became the technology licensor of Rewind PET. With the support of the French Environment and Energy Management Agency, this collaboration has resulted in the construction, commissioning, and recent startup of their Rewind PET semi-industrial unit.